Good morning, students. Today we will study second example of polymer, that is the polythene. So polythene is the simplest and the most commonly used hydrocarbon thermoplastic, has the following structure. So CH2 double bond CH2, we know it is a ethene or ethylene. On that, polymerization gives double bond is converted into single bond. So it is CH2 single bond CH2 n times. This is polythene or polyethylene. The IUPAC name of this polymer is polyethylene, is polythene. Polythene is of two types, two kinds. One is low density polythene and other is a high density polythene. In short, it is called as a LDP and other is a HDP. Low density polythene and high density polythene. So the first type is low density polythene, in short called as a LDP. So it is obtained by polymerization of ethylene under high pressure, that is of 1000 to 2000 atmosphere, and the temperature condition is 350 to 570 Kelvin, in the presence of traces of oxygen or peroxide as an initiator, and the reaction is CH2 double bond CH2, of course n times the traces of O2, peroxide at 350 to 370 Kelvin and 1000 to 2000 atmosphere, it gives LDP. The mechanism of this reaction involved is free radical addition and the hydrogen atom abstraction. This hydrogen atom abstraction take place, that gives the branching, and the chains are loosely held and the polymer have low density, therefore called as a LDP. Then some properties of LDP are given here. The LDP films are extremely flexible, but they are tough, chemically inert, and moisture resistant. It is a poor conductor of electricity with melting point 110 degrees Celsius. The uses of LDP, low density polythene, is mainly used in the preparation of pipes for agriculture, irrigation, domestic waterline connections, as well as insulation to electric cables. Here the some pictures are shown, that is about the uses. In submarine cable insulation, it is used in producing extruded film sheets, then mainly for packaging and household uses like preparation of squeeze bottles and attractive containers. So that is of the uses of LDP. Now the next type of this polythene is HDP. It is a high density polythene. It is essentially linear polymer with high density due to the close packing. Reaction is CH2 double bond CH2, of course n times ethylene, temperature condition 333 Kelvin to 343 Kelvin, temperature condition is 6 to 7 atmosphere, and in the presence of catalyst it gives HDP, that is high density polythene. The catalyst used in the preparation of HDP is a Ziegler-Natta catalyst, and it is the combination of triethyl aluminium, means C2H5 3 times Al, with titanium tetrachloride, that is TiCl4. The formula again I will repeat. This C2H5 3 times Al, that is called as a triethyl aluminium, and TiCl4 is a titanium tetrachloride. At the temperature condition 333 to 343 Kelvin, pressure condition is 6 to 7 atmosphere. The properties of HDP are: it is a crystalline, the melting point in the range 144 to 150 degrees Celsius. It is stiffer than LDP, has high tensile strength and hardness, more resistant to chemicals than LDP, and therefore mainly used in the preparation of these containers. So uses are: it is used in the manufacture of toys, then household articles like bucket, dustbin, bottles, pipes, etc. It is used to prepare laboratory ware and other objects where high tensile strength and stiffness is required. So that is about the second type of polymer. It is a polythene. Polythenes are two types we had studied: LDP and HDP. Thank you.